The demands of the market right now are exponential, from meetings on our computers to things we do on our phone. It all results in going back to a data center that has to house, store, process, and use that data to help us interact in the world around us.
You can see it all throughout business and your personal life today. It has become a part of all of our lives. You'll see it's not only people, but devices and things across the board that are taking advantage of these massive data sets and this massive compute power.
The compute needs to keep up with the demand. So at Applied, we are providing a product that allows some specialty parallel computing, high-performance computing, AI computing to exist and to thrive.
My name is Eric Grunstrom. I'm the VP of High Performance Computing at Applied Digital, and I build giant computers. We can provide fractional compute, we can provide entire clusters, entire supercomputers. So the way that it works is that we start consulting with Dell and Dell AI Factory about having them come in and help us build out the project. We have a space, we have power. We know what we want to do with it. We want to fill it with GPUs based on what a customer is asking for. We will build the internals of the server, how much storage, what type of networking, how many CPU cores are, and Dell is able to adhere to that and work our design around that. From there, we turn it over to the customer. We will essentially give them the keys to the car where they'll be able to get in and do whatever they want with the compute that is there. We do that, and then we build facilities for tomorrow's compute. So we have data centers that are able to be cooled purely with air cooling, and that meets the needs of today. The near future of computing is going to be direct-to-chip liquid cooled. So we have a massive expansion in North Dakota where we're going to provide that.
One reason why we really like the Dakotas, particularly Ellendale, is taking advantage of some of the natural cooling. My name is Brad Barton. I'm the Executive Vice President of Real Estate Development at Applied Digital. It takes a lot of energy and power to make water cold enough to run these training models. You've got a lot of heat to remove in the most effective way. Bringing water close to the rack through direct liquid cooling is a fairly new technology, where in prior data centers, that's pretty far away from a traditional server, because water is typically not good for electronics. Traditional data centers are 10 to 20 kilowatts per cabinet. We're designing for a 10x that, where we're up to 120 to 150 kilowatts a cabinet. What we've done is we've been able to find stranded power, stranded capacity. We've got 4 or 5 wind farms, so to say, feeding into our substation. This is also something that's really good for our customers. As we're harvesting a lot of natural and green resources, we're doing our best to give back to the environment by harvesting what Mother Nature gave us.
The Dell AI Factory has proven to be a valuable resource in a consultative fashion on the finance side and through providing expertise in our build-outs.
They're a large company with a lot of resources that allow us to understand things from engineering to practicality and how their systems need to run that really gave shape to the birth of our building. We're at the precipice of something even greater in the future, that this has to become the standard. So we look at ourselves as kind of early pioneers as we're building these data centers, purpose-built for high performance, high density compute.
There is a need for this massive compute power. It's all located outside of Urbania in places like this. I mean, this is like the real future. It is really a magical experience when we are able to tie all of these elements together. So many people, so many parts, so many elements to making it work, to see that go online and see that accomplish its intended purpose.